All right, let's give it another minute, waiting for Dmitry, who will be presenting right after my introduction. So we kind of got to have him on.
Ironically, it's the most hard to join this conference when you're organizer of it, because Zoom doesn't allow you to go with the flow. You have to do something else.
All right, I see him. Okay, I think we get the most important people on the call. So welcome to another awesome edition of the Fluence community call. Today we got a pretty packed schedule. Dmitri's going to have an update from the CTO office. We have multiple hackathon participants presenting their solutions. We have possibly Joera presenting part of his work in continuation from last week or the week before, I forget. And then we have Alexey from our side presenting the details, the by examples on registries, basically continuance from the high-level overview, the last call. And I think last but not least, our other Dmitry is going to quickly go over the Aqua CLI changes. Some of them are okay. Folex will do it. And yeah, so let's get going. Dmitry, all yours.
Hello. Well, we've been working on the registry and fixing various small issues all around that led to the release of the new Aqua 0.7 and the new Fluence.js version and the new compiler support v3 in the Fluence.js side. So a lot of small changes, but Alexey will show the result, the effect, how the registry can be used, because finally it's done, which is super good. And what else? And we have something not absolutely complete yet under the hood, but good news are about to happen, but not today. Let's focus on what was done on Alexey and the demos.
All right, Anna, you want to introduce our hackathon presenters?
Yeah, I can. Helmi, can you hear me? Or...
Yes, I can hear you.
Are you ready? Do you want to present today?
Yeah, sure.
Cool. Yeah, go ahead.
Oh, okay. So we're gonna start with my presentation right now. Okay. Yeah. So maybe I will just start right now and sharing my screen. Okay, I hope you can see my screen now, guys.
Yes.
Yes, okay. Yes, looks good.
Okay, first of all, my name is Helmi. and thank you for having me in this community call. So I was participating in these bounties for the beginner challenge that integrate the API from OpenSea and Raribles with the Fluence library. And what I built here with my friends, Nico, he's also here in the meeting. We are creating what we call with OpenPond. Basically, this is a very simple applications that listing some NFTs from OpenSea and Rarible. And I will maybe just demonstrating how the apps works. Basically, it's just displaying some items from OpenSea and Rarible. I guess there's a little bit problem from loading from the OpenSea testnet API, but you got the idea. So in the homepage, we are displaying some NFT items, and we can also connect our MetaMask here in Rinkaby testnet network to see is there any collections that we have. So I have connected my wallet here and the Rinkaby network. And as you can see, I got some collections from OpenSea and also from Rarible. I'm going to open from the Rarible one. There's quite takes sometimes. And as you can see that we can also open the NFT items on any collections that we have. So that is basically how the OpenPonds work. And maybe I'm gonna go through how it works from the system and code. So first of all, as mentioned in my GitHub documentations, that for the backend, we are using Marine Rust SDK, and we generated the WebAssembly, and then we deployed in some cross-node nodes here, so we can access it from the public address from anywhere. And yeah, so the Marine Rust that we are generating is coded right here. So you can see I have two Marine Rust I made here. The first one for accessing the variable testnet, and the other one is for accessing OpenSea testnet. And basically, it's just contained a function for getting all the assets here. Here's the testnet API, and then it also accepting parameters for the size of the items that we want to load, and also the continue token if we want to load on a continuous page, or if you want to load the next page of NFT collections. And also I create a function for the owned collections from the variable, and also the owned assets by the collections. And that basically what is I write the code in the Rust, and also the same here in the OpenSea Rust things. And after that, we build it as a WebAssembly, and then we upload it with a function here that will upload it to the cross-noder. And then I'm also creating the Aqua files here, so it can interact with the React.js. It can interact with our front end, as you can see here. It basically just tells where's the node supposed to be connected. And this is the node from the cross-noder I have uploaded earlier. And it's just some implementation of the Rust functions. And then from here, we built the Aqua. And it's outputting some TypeScript here that we can import in our main front-end code here. So I'm importing from the TypeScript that have been generated. And we call the function as easy as this, like calling the the Aqua interface and the functions like get all assets and setting the size of the items. And yeah, basically that is how the OpenPond works here. Yep, I guess that's all I can show you guys about the OpenPond. Okay, I guess I will returning to you guys. Thank you.
Okay, thank you very much. Anybody have any questions?
Yeah, I have one. So this allows you to like have some state about user on the Fluence service, so you can gather collections and stuff. Does it somehow enhances the API that OpenSea and Variable give you? That's my question.
I'm sorry, can you repeat the question?
Yeah, sure. Does it somehow give you, does Fluence here give you additional features that simple OpenSea and Variable API don't give you?
Well, basically it's not, we're just making the Fluence as a backend that requesting to the testnet API. So, I mean, basically if you request directly to the testnet, it can also be work, but I can see, as I see from the Fluence that we can actually change some request to be working in one direction. So I mean, from the front end, we can just request once, but in the Fluence, in the back end, they can change some requests. But for the challenge I participated, it's not. I mean, not as simple as requesting the assets is enough. So I'm not implementing some others complicated requests that maybe, you know, like if you get the collections ID and then automatically list all the items. I mean, I can do that with the Fluence, but unfortunately, I'm not yet implemented in this OpenPond challenge.
Yeah, I like the architecture that it allows you to implement more business logic on Fluence.
Yeah.
Great, cool, thank you.
So now, of course, the follow-up question is, when are you going to implement the additional business logic?
Yes. Yeah. Well, for the, I mean, from this bounty, I also at that time there's also some intermediate challenge that maybe require us to create a more complicated business logic, but I guess I have running out of time, so I'm not yet be able to implement the more complicated ones. Yeah.
All right, makes sense. When you're ready, reach out. We're happy to help you, and happy to obviously watch the project grow. And
sure.
Cool. Anna, do we have anybody else?
Yeah, sure.
Thank you, Helmi. If Rahul is here. Can you say something if you're here? Not sure, because you know.
Yeah.
Yes. All right. Welcome.
Hey everyone.
Hello.
Hello. So I'm Rahul Bansal and I will share my screen. I have participated in this BigNet challenge for custodial wallets API that tracks the NFT events on OpenSea and Rarible marketplaces. So I have just created this NFT monitor service using the Aqua framework, in which I have implemented two functions: send message and return result. In the send message, we are using the functionality to it implements the functionality for the peers to chat with each others. And return result, it just returns the result from the peer to another peer. I just have opened it there. So I have created a modal here where there is a peer ID and relay ID for each peer. Then we will copy this peer ID and disconnect with it. Now we can also enter the wallet address that we would like to track. I'll just enter this wallet address. Now we can also chat with the peer, like here. Hey, there's a message. Hi peer. Now we can also track this peer when he or she will create a NFT. Sorry for that. So I have this test JPEG, which I will use to create an NFT. So now it's listed. Now we can sell it here. You can set a custom amount for it like this. Complete listing. Now this peer has started monitoring this wallet, and which will return the result to this peer. So like in this OpenSea API, we'll just wait for like a few seconds. Yes, as you can see, like we have displayed this payment token used, contract address, the quantity, and the transaction block hash, and the created date. Like is this. This is the code for this. Yeah. The select relay, we have registered the services. When we are sending the message to the peer, we are displaying it in the console logs like this. Yes, that's all from my side.
Very cool. Thank you. Anybody have any questions? Well, I have a question. If you right now you have a lot of interactive components in there.
Mm-hmm.
Have you thought about making it more autonomous, so non-interactive? And if so, how?
Like, yeah, I have implemented the feature like for sending this images and like also, but yeah, I got unsuccessful in that.
Okay. All right. Thank you very much. Very cool. Congratulations to both of you. And who's next? I'm looking at Joera, but he doesn't know I'm looking at him because obviously this is
okay. Here we go.
It's a gallery, not a room.
Maybe you want to put. I would go in between the next two things or whatever. So I've been working on the project I'm working on, which is data aggregation using Fluence. So I get governance data of votes from DAOs on the blockchain, and I store them in an IPFS structure, and I also make a widget. And I talked about this 2 weeks ago. And since then, it's been running more stable, much thanks to Dimitri's suggestions. I've also created a little bit of confusion with regards to stability about some other nodes, but I think that's okay now. But in general, I believe it's working stably now, which is good. Then what I wanted to do, because what you saw 2 weeks ago was just an Aragon DAO, which I used because they have a reliable front end. That was easy for me. And so now because as a proof of concept, I want to use a different sort of DAOs and then have them produce the same data structure. So I was looking into the Open Zeppelin contracts, and I made one, and I made a form to do that. And then I wanted to incorporate that into the workflow. And then I really started doubting about whether I actually should use the graph, because up till now I've been like getting an event from the blockchain and then getting the data through the graph. And then I started thinking, I've just been thinking about whether I should keep doing that or just store all my own data in IPFS. And while I'm thinking about that, I thought I'd have a look at the new registry functions that you guys have made and talking about all the time. So I've been doing that yesterday and today, and I'm making progress with my mental map about what it's actually supposed to do. And I'll probably have a question tomorrow because it's not yet completely working on my side.
Okay, awesome. They're going well, encouraging.
I'll probably have a question when after the demo, because that's about the subject, right? I'm not gonna talk about it yet.
All right. Well, drum rolls. Alexey.
Hello, hello. You can call Alexey, and one of two will appear. That's handy. That's handy. Okay. So, do you hear me well? By the way, I have problems with Wi-Fi, so yeah. I suppose you do. Okay. So, what I'm going to talk about today is about this black window, or like semi-black. It's about the console utility that we have. You probably know it. It's the Aqua compiler. It has changed its user-facing side. Now it should be more understandable and easier to use. What I'll do, I will go through all the, well, most of the comments that it has, the most important ones, and we'll describe the changes and what they do. If you didn't know before, you will know. So this is an Aqua compiler. Its most important function is to compile Aqua scripts to TypeScript, JavaScript, or AIR. I hope you know what AIR is. It's our low-level language that describes all the orchestration. And Aqua is the high-level language on top of it. So Aqua, I hope you know what it looks like. If you don't, it looks something like this. You can like say where to go and what functions to call and what results to bring back or to don't bring any results. But for demonstration purposes, it's better to return results. So this simple script, let me make it bigger. This simple script goes to this node through this node, and it asks this node to identify itself and to return information. That's not very important. That's just like some background if you never seen Aqua before. So it does some network hops and then comes back to you with the results. What you can do with this code, you can compile it, of course. Let's do that. So let's first take a look at the help again. So since the most important feature of this tool is compilation, it's the default command. You don't have to like type any command, subcommand to do the compilation. You just type Aqua, you provide path to, let me make it this bigger too. You provide path, sorry for scrolling. You provide path to the input files. It could be a directory or it could be a single file. In my case, it's going to be a single file. So let me show what we have here. I have this demo folder and it contains script Aqua. So Aqua -- input, script Aqua, output like here too. And we have, by default, it compiles to TypeScript. So I won't go into the details. Yeah, I trust myself. I won't go into the details of what's happening inside the TypeScript. I will just say that here we have getPeerInfo function, and here we have this function too. So now you have compiled, like I have compiled Aqua script to TypeScript, and now you can, anyone can import this function in the browser or in Node.js application and run it, and it will return a promise with the data about the peer that we requested with this info. So great, we have compiled it to TypeScript. What else could we do? We could compile it to JS by providing --JS. It will create a JS file and type bindings, typings if you want to use this JS with TypeScript. Great. And also you can provide --air, and this way you will get a pure air code with some comments in there. It looks like Lisp. It's a low-level language. Don't be scared. It describes all the network things that this script have to do to perform its job. Okay. So at the core, the Aqua compiler always does the same things, like compiling to TypeScript, to JavaScript, to air. It's always at the core the same thing. It's always compiling to air. You see, it's the same air script in TypeScript. But when compiling to TypeScript or JavaScript, so many script words, it also adds bindings around air, so it's easy to use in the browser. Okay, so that was the compilation. Hope you bear with me. So let's see what else we have here. The most important work on, like, this compilation thing, it was there before, it hasn't changed, I guess, at all. Most important work was happening on the subcommons. So the goal was to make Aqua --help a thing that you can learn from. Like, you see that you do --help, you get this a lot of options that you might seem scary, but the subcommons, they should educate everyone who uses Aqua. It says that Aqua has the following 6 important things to do. It can run Aqua code and compile, of course. It can manage your key pairs that you, like private keys, public keys that you use to run Aqua scripts, or you can manage in browser. IPFS doesn't matter much, but you can connect to IPFS node and get files from it, stuff like that. Doesn't matter much. What matters is the managing scheduled scripts. It's the script subcommand. It allows you to schedule cron-like jobs on the network that go on, run every 3 seconds or 5 seconds or 7 seconds. As you say, you can specify the interval, and the script, Aqua script, will run on the network, like on some specific node, again and again and again until you remove it. You can interact with the remote peer. That's one of the most interesting subcommands here besides the run. We will go into detail, but basically you can say, hey, this peer, deploy service, remove service, stuff like that. And some configuration that's mostly non-existent right now, but it's an important thing, will be evolving. So we have made it a separate thing. So we saw the compilation. Now let's look at how we can run the Aqua code. But before we can run the code, compiling didn't didn't require us to connect anywhere. You can just compile and have files on your local file system, and that's it. But if you want to actually run Aqua code, you need to decide where you want, how you want to connect to the network. You need some entry point, some relay, some node, and you need its address. How do you know it? You can like Google Fluence peers addresses. Maybe if Google indexes our documentation, you will get to the right place. But it's like, it's a hard way. It's not very handy. What's handy is just type aqua config if you forget the full command, and you get default peers here. So it lists, as it says, it lists addresses of default peers in Fluence networks. That's the peers that we know about or we might maintain, and we provide you here so you can copy paste them or use in any way you want. That's just a static value. It could change only or on Aqua release. So let's take a look at it. So here we have like a default environment. It's called Krasnodar, and all the nodes like Kras 00, Kras 01, and so on. There are 10 of them. 10 nodes, but 11 Fluence nodes. 10 hosts, but 11 Fluence nodes, because the first one hosts 2 Fluence nodes. I guess that's kind of confusing, but it's really easy. It's just an address of the node you can connect to. So that's nice. Let's actually run the Aqua code. How we can do that? Let's take a look at the help. Wow, it's a big one. It's a big help. But we already saw how compilation works, so run is alike to it. So what we need to provide is we need to provide input, right? Like path to a directory with Aqua files or just path to a single Aqua file. We have run Aqua, which is here, right? And we also need to provide address to connect to. But that's not all. So let's take this address. And also we need to provide a function that we want to call. Like, let's take a look at the script once again. So we have this run Aqua. It has a single function, but it could have more functions, right? Like, and in this case, when you run, you can't just run a file. You have to specify which function to call from the file. So in this case, we need to provide minus func, what's its name? Get peer info, we just copy it, and we need to call it. But there is a problem. Oops, sorry for that. There is a problem. It takes an argument. So you have to pass an argument, right? Let's take a look at it again. It takes a peer ID to, like, it takes argument that says where to go to call the function, like network address. So let's provide it. In this case, it's not the whole address. It's just this part of the address. So like this part of the address, it specifies the first part. It specifies DNS name and the host name, like where to connect and to what port through WebSocket. But this part specifies the public key of the node. And when you have public key of the node, you can always discover node in the network. So Aqua scripts internally, they operate not on this TCP part, not on this. They operate on the public key part, which is also called peer ID because its peer ID is derived directly from public key. Okay, so we have this. We have Aqua run, this file, connect to this node and call this function, like get peer info, passing this parameter as an argument. Let's do that. There is no path run Aqua. There is no path. Tempe demo. What am I doing wrong? Ah, it's not run Aqua. It's sorry. It's script Aqua. So we call it and we receive the data returned by the node. So we have run Aqua script, and it's very useful tool for debugging. Like whenever you report a bug, if you make report in a way that's runnable through Aqua run, I will love you forever, for real, because it makes debugging and understanding your reports so much easier. So please always include Aqua run command to reproduce your problem if you can. It's not always possible, it could be hard to understand, but if you can, please do. That makes our work so much, it makes it so easier to help you, and we can help more faster. Great. So hope you're still bear with me. If you have any questions right now, just tell them, just ask them. I'm gonna clear the screen. Yep. No?
Oh, well, I can go. So my first thought is that you really want me to stop using my sort of TypeScript functions that I use to do sort of similar things.
No.
No.
It's
We
great.
want you to stop using FLDist if you have used it before.
No, but I there is like sort of this sort of functionality, which I repeat a lot of times, and then I write a little function for it, and so that I can use an npm command. But it's also true, but what you said at the end is that if we all use the same methods, the same way of looking at things, then it's much easier for me to contact you and ask you a question, you know?
Yeah, that's true.
Over the past days, it can get sort of confusing when I'm using my own code to do administrative things.
Yeah, but this is a very simple tool. It's powerful, but real simple. And in your case, let me give you everyone some background. Joera recently gave me his awesome project, and there was a problem that was hard to debug, and I have to like read the code and run it. And what I was doing, I was taking your code and running it through Aqua run. Like it wasn't hard. So you can have TypeScript, complex TypeScript things automated through package.json and npm run. That's totally fine. We do that as well. But sometimes when you and I debugging stuff or just want to test some simple thing, it's easier to use Aqua run. And for bug reporting, Aqua run is just a blessing, but it's not always possible. Sometimes you don't know where the bug is, so you have to report the whole project. So don't make that stop you. If you find it hard to translate your problem.
But things are hard, and then you find the easy solution, but then you don't learn how to do it. Well, I'm being honest here. I had one other thought. Can you make this client could have been written in? Could you make this client
listen
a Fluence application?
You mean like listen for incoming requests? Is that what you mean?
Because you can, I believe you can write something like this in Rust, right? That create console logs. So if you connect to a local node, and from that local node, you have services that do this stuff, and then you can be in connection with the network. Anyway.
Yeah,
well,
I want to follow up on that. So I have two questions on it, and one was, can we use it as a listening client as well? Can it take incoming via relay?
That's functionality is planned, but it was in FLDist before the previous tool that we have that we deprecated with this new stuff, but it's not right now in Aqua because we asked around and no one wanted it. So if anyone would start wanting it, we will add it.
I want it. And the other thing is, how do I now in Aqua config? How do I get the addresses from testnet or stage, for example, other than just the default?
That's a great question. Let me show you. So like we have Aqua config default peers. It's a little bit like it's a little bit hard to get, but like to understand. But here in help, it says that you can pass Krasnodar stage or testnet as an argument. So you can pass here testnet, and you will get it.
Okay, that's all I wanted to know. I wanted to have it on video because obviously people who used the tools before, coming from FLDist, it's a little bit different and a little bit more nesting, but long term, I think the nesting will not lead to backward breaking changes anymore. So I think that's really, really good news, hopefully, but I think it's much more robust than what we had before. So anybody who's been using Aqua for a while or FLDist, I know you're going to have a little bit of pain updating your scripts and your code, but this should future-proof you quite a bit.
You talk from the experience, right?
I talk from the experience, yes. Okay, anybody else? Any questions?
And I still have and after questions, I will describe how Aqua Remote works. Yeah.
I think Evgeny had a question.
No, my question was very stupid.
Okay, all right.
How
Then,
does Aqua Remote work?
Yeah. So Aqua Remote allows you to interact, let me clear everything, allows you to interact with the remote peers. Like all peers are remote, except local ones, right? But here you have commands to interact with the peers. Like you know, I want to deploy to this node. So this node is my remote peer. I want to deploy there. I want to remove service there. I want to interact with it. So I'm here, it's there, so remote. So it's mostly the same as it was in FLDist. Here we have a way to deploy service from WAS modules. Like you provide the usual configs, it uploads it and creates a service. You can remove service. And if you already deployed service before and you already uploaded the module and you have blueprint ID, so for more like advanced use cases for performance reasons, you can just use create service instead of deploy service to avoid re-uploading modules every time. You can just recreate the same service again if you want it. So add blueprint is just an internal mechanic. If you want it for truly advanced use cases, usually you're covered with this free. So those functions, those commands, the four last commands are more like querying the peer. You can ask it, what WebAssembly modules do you have? For example, let's do that. So Aqua Remote, first I will do Aqua config default peers, because I want to take some peer like this one. Then let's do Aqua Remote other this, and I want to ask it to list all WebAssembly modules that it have. It will have a lot of modules, so I will put the command into the less so we can scroll it. Why? What? Let's do it again. Unexpected option other. I always forget that you have to put, I always do that mistake. Maybe we should fix it like on the CLI side, but what you always have to do right now is you always have to write the comment right after the remote. So in my case, it was a mistake like this. I first entered minus other and then only then I entered the comment. So that's not the way it works. Okay, minus other, list modules, and put it to less because it will be a big one. So yeah, you can see that there is a lot of modules. They have their hashes, they have then config files, they have their names. So that's all WebAssembly modules that were ever uploaded to this node, to like this node. Great. So this is a querying stuff. You can query some information you want to know about node. For example, if you know you have a service, but you don't remember or don't know, or someone else has a service, but you don't know what functions it has, what's its interface, you can do get interface -- ID, for example, Aqua IPFS. Like, yeah, we have this service, Aqua IPFS, and it will give you a big JSON that describes the interface of the service, of the facade module of the service. So, for example, here we have function with name set local API multi-addr that takes one argument, multi-addr of type string, and so on and so on. We have a lot of functions. Sorry for scrolling. Like we have get from function that allows you to download file from some node. You can provide hash and you can provide external multi-addr, and it will download the file from external IPFS node to local Fluence node. And after all the functions, at some point you will start having types like structs, like for example IPFS multi-addr results. Yeah, so this is like, there are first definitions of functions, then definitions of structs that it returns. So if you want to know what is IPFS get result, you can just do that, and under record type you will find IPFS get result, and you will see that it's a structure with 3 fields: success, error, and path, and its types you can see as well. So I guess list interfaces is now more or less obvious. It just shows all interfaces of all services that you created on this node. Yeah, as it says, lists all service interfaces on a peer by a given owner. And since it's a peer-to-peer, it could say on a peer by a given peer, but that would be utterly confusing. So, and that covers all the major changes that we have. Let's take in Aqua CLI. Yeah, so that's it from my side.
All right, very cool. Thank you. Anybody have any final questions? If you think of something later, hit us up in Discord. Ready to jump in, or Telegram for that matter. All right, one Alex to go.
Yeah, it's me. Now I want to present you some little demo for Registry. Let me give you some context. Service is an essential part of a Fluence protocol, and it's if you want to call some service, you need to know his coordinates, like service ID and peer ID where it's hosted. You can deploy services, redeploy it, but it's handy to have some stable identifier to find these services, like in APNS. So for this, we need some mutable registry, which can be used for advertisement and service discovery. And if there's 2 types of services, one type is on full-featured Rust node and can be found only by peer ID of this node and service ID. And second is services on JS peers. JS peers is not fully featured, and to call some service from our peer on JS peer, you need to know relay to which this JS peer is connected. So there's 3 unknown and parts that can change in runtime. So it's will be handy to have some registry to store these identifiers. So I want to show how to register service on JS peer and find it and call from another JS peer. Let's say we have greeting service that just accepts name and returns strings like hi name. So firstly, we need to register this service on our JS peer. This is default step for JS peer. It can be found on Fluence Node.js template. So firstly, we need to register our service with some service ID, like my greeting service. We register function to greetings that just logs the message and returns concatenation of a hi and name. So export Aqua looks like this. It just import greeting service from our service file and exports this to TypeScript. And it's all compiling. Okay. Next, we need to advertise this service. If we wanna find this, if we wanna discover this service on our JS peer, we need to know the route to this peer, like relay ID, peer ID, and service ID to call this service. So we need to create route and register for it. Routing MP is designed for such things to register routes and discover services. So we import this function in export Aqua and import it in our TypeScript file. 1 second. Oh, I forgot to export it. Okay. Route have a label and it's label unique for each peer ID. You can use any possible string that you want, and for each route we have records which represent providers of services on this route by this table identifier, and we have some value in these records, and you can use it as you want. Like it can be specified by business logic. We don't need it in this example, so we just put in any string to it. If we want to create and register route, we pass label, value, our relay ID, and service ID of our registered service. And it creates route and records in the registry and replicated to the neighborhood with information to discover this service, like service ID, peer ID of our Fluence peer, and service ID of our greeting service. So with our JS peer, this code needed to just wait and not exit, and we can run it. Okay, we connected to Fluence network with this peer ID to this relay, and this is our route ID. Now route ID is just concatenation of the label and our peer ID, as you see, but it's for debug purposes, and later it changed to hashes. And now we need to, from an our peer, discover the service and send our name. For this, we need to have greeting function. Where's our greeting function? Acquisition is a number of node which we want to ask about our route, and route ID is route ID from this output. So if you want to find all providers of this route with these services, we just call routing API resolve route and go through providers and call this service on this peer ID via this relay and resolve service ID on this peer and call the greeting function. Result client, it's very simple. It just accepts route ID and call greeting function. Let's try to call it. Just copy route ID and okay, it's returned out to us. Hi, Alexey. And as we see, we received our message in the server. So it's demo about registering, is about advertising and discovering services in JSPeer, but you can do the same with services on the node. And whereas API in routing, it's called the same, but with postfix node. I can show you as well. Yeah, it's create and register node, and you can pass all the things which passed in previous function, but you need to pass node ID. So that's all.
Very cool. Thank you. Anybody have any questions? I'm looking at you again. Joera.
Yeah. I have a lot of, well, today I had a lot of questions. Some have somewhat been answered.
Okay.
But I'm still confused. And that's not, that's just going to take a while before I start getting it. Because in my idea, it's like a way for other nodes and peers to give permission to do something on their nodes. Well, that's the way I'm thinking about it. Maybe that's wrong. So you open a route, you create a route, somebody creates a route with an idea of a task they want to have performed. And then other nodes or peers, or well, other peers, they will say like, okay, I wanna perform that task. And then because they register themselves to the route, then that function from the original peer can be run. That's how I see it. Maybe that's already wrong. Yeah, this happens so fast that I'm wondering where is sort of the permission from the second peer. Where does the second peer say like I'm also registering?
So talking about permissions, now anyone can register for route of another peer without checking permissions, but in the next iteration we will add trust graph to it, and whereas crypto proofs that can be checked if this peer can register for this route or not. And yeah, now it's not managed, but it's planned and everything ready for it. So now anyone can register route, tell somewhere, advertise it, and everyone can register for this route and provide services, but no permission checking, like only signatures that this peer added this record or this peer registered this route.
Okay, but who provides the service? The person that is registering or the person that created the route?
Okay, route is just route ID and metadata of creator, and later it will contain challenge for permission checking. For route can register peers with records with service ID, peer ID, and relay ID, and so these services can be hosted on JS peers and peers provided with services, or the services can be hosted on nodes and provided by our nodes.
Okay, so create route and register here on line 22. I interpreted that as that I was creating a route and registering myself to it.
Yeah, that's true.
Okay,
that's true. If it's create route and register node, so it will be advertised node service on RAS node. Yeah.
Yeah. So this by now is working after I updated everything correctly. But I'm having troubles with like registering another peer. And the problem is that the weight that should be gotten from this trust graph is not returning anything. But I'm gonna ask you about that tomorrow or Monday.
It's strange because in for now trust graph there is no problem with trust graph because it's like not used at all, but just gets zero weights and put zero weights in registry. But okay, you can touch me in Fluence Telegram channel or Discord.
Yeah, I'll bother with with this tomorrow.
Yeah, what API do you use? Do you use this routing Aqua, or do you use something directly? Like, are you calling the registry service directly?
No. Well, of course. No.
So you're not expected to do it. And
Alexey told me to only use the routing methods in routing. But when they fail, I try to investigate where the problem is. So then I use the other ones.
In this case, you should follow the invariance tetraplet checking invariance. So you have to query the trust graph on the same node to provide the weight. Otherwise, it will not take this argument. So this relationship between the services is enforced by the tetraplets. You cannot just put the number here. You cannot fake the weight.
No, but yeah. Well, let's. When I return like the object that is created for the weight, that's like weight result or something. Then it said this it's an object with everything is undefined.
Super strange. Yeah, we should investigate it.
But it's I'm gonna ask about it tomorrow. What else did I wrote some things down.
So this demo was about routing the requests to some service over the network. And permission checking for this routing is a natural companion. That's Trustgraph, but it's not covered, but we are going to cover it hopefully in 2 weeks, ideally, hope so, but maybe in a month. Will do.
All right. On that note, anybody have anything else? Anybody want to present something? Want to mention something? Want to ask a question? Well, in that case, it's been awesome seeing you all again, and looking forward to see you in 2 weeks with hopefully a major update in the companion to Registry. And before we watch them terrorize the cat any further, I hope you're all a little bit more awake than the cat there. But other than that, it's been great. Thank you very much. And I'll see you in 2 weeks. Cheers.
Thank you. Bye.
Thank you. Bye-bye.